So congruent triangles. This one's a little bit weird. I feel like it bounces around a bit, but we'll try to keep it as streamlined as possible. Congruent right triangles have the exact same size and shape, just like our congruent triangles from before. Their three pairs of corresponding sides are congruent, so you see the 12 matches with the 12, with the 13, 13, 5, and I guess I should have a 5 over there. And their three pairs of angles also correspond, so you have the 23, the 67, 67, and then the 90s match. So remember these congruency statements. For your sides, you pick two of the letters. So A to C, that's the small side. So I need the other small side, D to F. And I'd write the little congruency side. Angles, you just have to match up the letter. So F is 67, so that matches with C, which is 67. If you remember, we had before like side, 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 and side, angle, side, these like shortcuts to prove congruence. We have the same thing here. I'm not going to read through all of this, but you have HL, which is hypotenuse leg. So if you know the measure of the hypotenuse, so like we have up here, we know the hypotenuses are both 13, and then one of the legs, so we know that these two are both 12, then we know every other part would also be congruent. So that's one way. The leg-leg theorem, if you know both the legs, so you don't know what the hypotenuse is, but you know the legs match, then our triangles are congruent. Hypotenuse angle, so if you know the hypotenuse, the longest side, and one of the smaller angles, the 90 degree does not count here. The 90 degree doesn't really count in any of these. So you want one of the acute angles. Or the leg angle. So if you know one of the short sides and one of the angles that's not 90 degrees, that also works. Yeah, I'm not sure if this is important. It may be something you see on the quizzes, but the hypotenuse leg is a special case of the side, side, side. You just only need two of the sides. The leg is a special case of the side, side, side because you got the two sides, and the side angle side because it would sandwich that 90 degree. The hypotenuse angle is a special case of angle side, so you would know technically the 90, some other angle in the hypotenuse, and the leg angle is either angle side or side angle side. Again, that might be something on a quiz. I don't think you're going to be asked about it much. So what does this look like? What you're doing on these ones, kind of like what I did before, you find your markings. Well, this, you want to ask yourselves if it's side or leg or hypotenuse. This is a leg. Nope. So this right here, AC is a leg. It matches with CD or DF, sorry, which is a leg. I don't care about the 90 degree. We ignore that. And I see this angle's been marked on here. So that's A. Which means this is leg angle, or the LA theorem. So it's the same thing that we did before. It's just, you really only have to mark two things now. You should only have two letters. Your options are an L, an H, or an A. That's all you have to choose from. So my next one, I see I have a leg over here that's been marked. And then this is my longest side. So this is my hypotenuse. So this would be HL. I have actual numbers on here. This is my longest side. This is the side across the right angle. So this is a leg, which matches with this leg. Then I have this other leg, which matches with this leg. This is LL. And in this one, I have this number here. Those are angles. And then this time I'm given my hypotenuse. So this is HA. So that's the first part of this. I think that will probably be most of your first quiz, just kind of differentiating between these three. Really just look for these three letters and you should be fine. Okay, so the distance from a point, so some point, like you can see here, this point C. Sorry. So some point, actually I think I jumped down. Some point to a line, so you see this line down here, AB. So the distance from the point to the line is perpendicular to the segment it joins. Okay? Perpendicular, you see it makes the 90 degrees. So we really have a triangle in here. You have like this 4, 9. We could solve for a missing side using Pythagorean theorem. I don't really understand these questions. I hope you get some of these on Apex because it says, what is the distance from C to AB? Well, it's just that 4. Likewise, that's just 1.5. Again, I'm not sure why they have that question. Things I will never understand. Then the last thing they give me are these bisector theorems. You can read through them if you want to. But here's what it means. It wants to know this. C to B. Okay? We know these theorems to be true. So we know that CD, this line in the middle, is bisecting. When you bisect something, you cut it in half. So you can see the 2 equal 10s down here. Well, that also means my outside is being bisected, or the lines on the outside should be the same size. So I've got 10, 10. If this is 21 out here, this has to be 21 out here as well. So the distance from C to B is 21. So it's just like you're cutting the triangle in half. It got 2 equal halves. And it works for angles as well. Okay? So I know these two sides are both 15. They're equal, which means this has been cut perfectly in half, which means if this side is 31, this side is also 31. So that's that. I'll work with you guys more, and hopefully we'll get through this section. Have a good day.